Graphical design concepts. This lecture video, by the way, it is a work in progress. This is the beginning stages, and I only have the loosest of topics in here to get started. So expect this lecture to disappear and change and get updated in the future. So here it goes. Here's what I got. Typeface and fonts. So we have two words that we use, fonts and typeface. Font is the very specific alphabet. It is one style of letters and symbols. A typeface refers to really a family of fonts that coordinate and go well together. Maybe one is used as a heading, another one's used as the body text, but they have a similar style and they go together as a family. Within the typefaces, we have what are called serif fonts. Serif fonts have these little strokes at the bottom and the top. And notice this forms sort of a line at the bottom. And this helps guide your eyes along. So sans serif or no serif means no strokes. And these really are for presentations anyway, these are the fonts that really we should be using much more often. They're more pleasing to the eye. However, if we have line after line after line after line of text, it becomes harder to follow these than it does a serif font. Then, of course, we have these decorative sort of display fonts that are really cool looking, but we would not want to read a textbook, for example, where this is the font for the body of the text. That would get overbearing. Then there's script style text, and this is another font we don't want to use for just line after line after line of text. And when we use this, it implies something a little less formal. It's handwritten, it's personal, but anyway, use it for that. And then, of course, symbols and dingbats and all kinds of other things that we'll use. So as I mentioned, the serif fonts, they help guide your eyes, and the sans serif doesn't have that. Now, our eyes are drawn to these. That's why our eyes can follow it better. But because our eyes are drawn to this, very often we don't want that. If we're just giving a font as a header on a slide, we don't want all these little details to draw their eyes to it. So we're using the sans serif. These can be very overbearing to look at. And there may be special applications of that. If I'm doing a movie poster and the movie's about a newspaper, I might want the title font to look like the font in the newspaper or something like that. So there's no hard rules here. But for the most part, in presentations and posters, you won't want to ever use serif fonts. Reserve that for the body text of documents. So almost everything you do outside of body text and documents will be sans serif fonts. So general rules, we don't want to use too many typefaces. We want to limit how many different fonts we use. We always want to use well contrasting colors. For example, these two on the right are very easy to read. These are, this red blue, maybe we can read that, but something about that just hurts my eyeballs. And this one down here barely has enough contrast to see. So we want to pay attention to that. And yellow and blue seem to look really good together. Black and white seem to look really good together. Give that some thought. These fancy display fonts, they're fun to use, but in a professional setting, you really want to limit their use. They may have a use from time to time, but think 2 or 3 times before you use something too fancy. You want your text that's easily read, easily scannable. You can use bold for headings and less bold for the fonts underneath and stuff like that. So, and also when you're using different types of typefaces, you tend not to want to distort them. So for example, you don't want all the text throughout a document to be italicized. They just don't look as good that way. Reserve that for very special cases. Equations, this is huge and almost everybody gets this wrong. The rule is the only thing in a math equation that should ever be italicized is the variables, and the one exception of that is uppercase Greek letters. For some reason, we don't italicize. I don't know why. Okay, so let's go through some examples to drive this home. Cosine theta looks good, right? Is this the correct formatting? It's not, because theta is a variable and it should be italicized. Let's go to the next example. Okay, is that the correct formatting? If not, what's wrong? Well, it's not the correct formatting. COS was italicized. These are not variables. C is not a variable. O is not a variable. S is not a variable. Those should not be italicized. So cosine in this case is not italicized, just the theta. All right, what about this? Is that correct formatting? Cosine's not italicized, theta is. It's not. The parentheses aren't correct. Whoever typed this just typed a parenthesis, a theta, and then the other parenthesis, and that's not correct. And in a math editor, there's actually usually a special operation to enter parentheses to put stuff inside. And notice these parentheses are bigger than the theta. That's not the case over here. So this is easier to read as an equation. So use the correct parentheses in your equation editor. Don't ever just type inline equations. Microsoft Word, for example, has a very good inline equation editor. Use that, don't type the equations. Okay, so now we're doing vector calculus. Del dot A, divergence. Is this correct formatting? It is not. That dot is not correct. And I've actually seen this in some textbooks, and it's lazy. That's not correct. It's a big dot for a dot product, not just a little period. Okay, so P average, maybe it's an average power. Is this correct formatting? And I see this a lot, even in textbooks. This is not correct. Why not? It's not correct because A, V, and G are not variables. They should not be italicized. The only thing here that is a variable is P. That's what should be italicized. Always use the correct symbols. Multiplication. What is the correct multiplication? Holy smokes, we have a lot of multiplications in STEM. So we have just A written right next to B, which just implies standard multiplication. We have a little dot, which usually still implies just standard multiplication. Then we have the star. What does that mean? Is that multiplication on a computer? A lot of times that'll mean convolution. We have a cross. Sometimes that can mean just standard multiplication. Other times it means a vector cross product. The big dot usually means a vector dot product. And then this other thing, which can represent other types of operations like convolutions and star products or other things. So pick the correct symbol for your operation and be consistent. Let's talk a bit about pictures. When we paste a picture in, we don't want pixelations. This one on the left, that looks very, very ugly. The one on the right looks clear and crisp. And pixelation can happen. We can paste in a picture that has the right pixelation. We close the document, we open it, and for some reason that particular program has erased the resolution. Don't know why that happens sometimes, but it's always bad. You don't want pictures pixelated. So don't be lazy. Pay attention to that. So let's say we have a presentation and we're discussing a fancy satellite dish that we were somehow involved in the project. Well, our eyes are drawn to contrast, and we don't want to lose people's attention. We want their attention on that satellite dish. But I don't know if you remember, where did your eyes go first? Probably the corners. That has the most contrast, and that tends to be where people's eyes are going. And if we're discussing that satellite dish, there's no information in the corners. Where would your eyes go second? At the edges. And again, there's no meaningful information at the edges. A great example of artists that use this is in movie posters. And they can imply concepts where they can engineer where your eyes go first, second, and third, and they can step your eyes across the movie posters. And a lot of times these look so simple and you don't realize all the intelligence and the thinking that has gone into these things. So one quick ugly thing we can do is just simply blur the edges. Now, boom, your eyes go much more immediately to that satellite dish. Even better, somehow erase all of the background and just have that satellite dish and nothing else. But a quick dirty trick is to blur the edges. Let's go on to labels. So let's say we want to label our satellite dish. We already know to blur the edges, but let's be a little bit lazy. And we want to draw an arrow. Well, notice this arrow is a dark arrow and it's passing through a dark region. We no longer see that arrow and your eyes kind of lose that. And if there's multiple arrows going on, we can really get crazy. So, all right, so let's use a light arrow. Well, you know what? We're losing the arrow here. We're losing the arrow here. I think it looks a little better than the dark arrow, but we're still losing it. So what do we do if we have a picture that has light and dark? Well, one thing we can do is use, for example, a dark arrow with a light glow. And now no matter what background that passes over, we see the arrow the whole time. So glows around the arrows, I think, are very good. And I do that almost without exception now. Color, this is work in progress. I've just started making this section, so I'm going to be lazy and just skip right over it and go on to the next section. Expect more here later on. Layouts and some good things to consider when you're laying out a slide. So the text here is completely messed up. That's intentional. It's meant to not be readable. However, just from the way this is laid out, we can tell that this is sort of a step-by-step. It's conveying a flow of something. And so if you're conveying a step-by-step, consider doing something graphical like this and not just throw text down, but throw graphics here that tell a story. And while I'm talking about text, I think you can make a very good presentation that has absolutely no text on any slide. Whereas if you start loading up your slides with all kinds of text, I might ask you, why is that even there? You're giving a presentation. You're supposed to be saying this stuff. Why do those words even need to be there? So what I tell my students when they put together a presentation, I tell them, suppose every time you put a word in your presentation, I'm going to make you write a 2-page essay on that word. Why that word needs to be there, the history of that word, what would happen if you remove that word, and so on and so on. 2-page essay for every word you use in a presentation. How would you do your presentations? Keep that in mind. Don't put too much text on your slides. At the very least, the person's going to be reading that stuff that's listening to you and not listening to you because they're reading. So don't do that. A really great way to lay out a slide, and this isn't the only way, but something called the rule of thirds. And if you can look at your slide and essentially divide it into thirds, and this gives you a bunch of options, it's a really effective and very eye-pleasing way to do that. So you essentially divide a slide into thirds, right? And so here's a few different example layouts that's following the rule of thirds. We have text in the first third and a picture in the last 2/3, or likewise a picture in the first third and the text in the second 2/3, and so on. And those are very effective layouts, and they're very pleasing to the eye, and it also creates some visual interest. We'll end this with a quick overview of some graphics software. So for manipulating photos and images, and there's going to be a whole bunch of different opinions on this, so I'll just go into it anyway. But the commercial king, I think, for manipulating photos and images is Adobe Photoshop. I know there's also Corel Draw and many other things, but let me just get away with saying I think the commercial king is Adobe Photoshop. If you have access to that, that is an awesome tool. If you're an open source type person, GIMP is a very good software package that they don't say they're a Photoshop clone or a Photoshop equivalent, but they really do similar things, and GIMP is also a very strong package for manipulating photos. So you can do things like adjust lighting in your photos, or remember the blurring in that satellite dish image. You can do stuff like that. You can remove backgrounds to remove contrast and make things easier to interpret. So having a good photo editor for your documents is very important. Vector graphics. Now this is important because you can draw a square and you can zoom in or zoom out, and you can control the resolution of these images much, much better. The Commercial King is another Adobe product. It's Illustrator. I know that's not the only one. I would call the open source king for vector graphics Inkscape. 3D modeling and animation. So in the commercial world, for engineering, I would say SolidWorks. I know there's Pro-E and there's CATIA and other things, but SolidWorks is really emerging, I think, to be the king in the commercial world. And that's for engineering. Now for art, Maya is probably the king in the commercial world. In the open source, for engineering for CAD, for solid models, there's not a whole lot of options. I'll throw out FreeCAD as the king there. For artistic, Blender, and Blender is absolutely awesome. It's one of my personal favorite pieces of software, and it's something I would recommend that everybody learn how to use. Now, the screen image here is a very, very old version of Blender. It's much improved now. Version 2.83.4, I think, is the latest as of the recording of this video, and I would highly recommend that. So Blender and Maya, think of these as the program that Pixar would use for creating their animations. So there's a lot in Blender. It has a modeler, so you can sculpt, for example, the robot-looking thing there, or scientific gizmos that you want to communicate. You can animate things very easily. You can render them. You can do photorealistic rendering. It has a timeline, so you can do all kinds of cool 3D animations. It has a Python sorry, I'm speaking too quickly. It has a Python API, so you can also, it's programmable, and that gives you infinite flexibility in what Blender can do. I highly recommend downloading and learning how to use Blender. For laying out posters, pamphlets, etc., don't ever use PowerPoint for that. PowerPoint is meant to make presentations, and it does that job very well. Everybody seems to use this for laying out pamphlets and posters. It is not meant for that. It can't control resolution or colors nearly like other packages, so don't ever use PowerPoint for that sort of thing. The commercial thing is InDesign. That's the top right now. Microsoft Publisher, that very often comes along with Office or is installed with it and looks similar, so I would have to recommend Publisher. The open source king is Scribus. That does a similar thing, but again, don't ever use PowerPoint. It's not meant for that. It's lazy. It's amateur to use PowerPoint for that. For text documents, commercial king is Microsoft Word. I think the open source king is LibreOffice, although I know that there's other options, but I'd say that those are the big two, and Microsoft Word is the preferred. In academia, you get this essentially installed for free. It's not really free. Your tuition is probably paying for that, but since it is paying for it, you may as well go to the university and get that installed. So Microsoft has made that very inexpensive for academia, and I think it is the most powerful. It is better than LibreOffice, although LibreOffice can still do almost everything that Microsoft Word can do. The main problem, I think, is compatibility. It's not 100% compatible. They claim 99.99%, and it probably is, but I don't think it's up there enough to, if you have the option of having Microsoft Word, I would not use LibreOffice, but LibreOffice is awesome. For scientific data visualization, I'm sorry, you cannot beat MATLAB for ease of visualization. Now, MATLAB itself may not generate the best looking of diagrams. I think there's better packages for that. But if you have a set of data and you just want to get that visualized quickly and easily, I really don't think you can beat MATLAB. And if anything can, I'm interested in trying it. Now, the open source king. I'm going to throw out Octave, and I'm going to say that only because it is the most compatible with MATLAB. I'm not going to claim that Octave, just for a scientific computing environment, is the best. There's other things. There's Scilab, there's even Python, and many other things. But for compatibility with MATLAB, Octave is definitely king. From the bottom of my heart, thank you very much for watching this video. I love hearing your stories about how these videos helped you. I also love answering your questions. So please tell me your stories and ask your questions in the comment section. I promise I will try to answer every single question that's asked. If you like this video, hit the like and subscribe button. I also recommend visiting the official course website that has links to the latest versions of the notes, the latest videos, and there's lots of other resources to help you learn, including implementations in MATLAB. I'll see you in the next video.